Hi everyone, welcome to my YouTube channel. In this tutorial, we are going to do a conduction analysis. So we have a bar of having a dimension of 1 meter here. Here this is 1 meter and this is 0.5 meter is the width and 10 meter is the length. This length. So what data we have this bar is made up of steel and thermal conductivity is given, that is 60.5 watt per meter square, and heat flux is given here, that is 100 watt per meter square. So at one end we are going to apply heat flux here, and we have temperature at the end of bar 100 degrees centigrade. So here we are going to apply 100 degrees centigrade temperature. So this data has been given to us. So now what we are going to do, we have opened this project screen, and here we have taken this steady state thermal and geometry also we have imported. Now double click on model and we will be in the mechanical window. We are going to generate mesh. Mesh has been generated here. Now we are going to apply insert heat flux at this face, apply, that is 100 watt per meter square, and insert temperature at this face, apply, that is 100, and now solve. So now it has been solved. We are going to insert thermal temperature here and reaction probe. Okay, right click and evaluate all results. So now you can see this is temperature 100 degree it is at this point, minimum, and maximum is 116.53 at this point. If we see reaction probe, that is 50 minus 50 watt it is coming at this point. So heat flux was 100 watt per meter square, and that cross section is 0.5 multiplied by, here this 0.5 multiplied by 1. So this is cross section. So if we multiply this cross section by this heat flux, then it will be 50 watt. So that it is showing 50 watt here. So now we are going to calculate temperature. If you see temperature, it is showing 106.53 degrees centigrade. So, and if you go to results and maximum and minimum, maximum will be on this face only. So that we are going to calculate how by hand calculation to match like we are in a right direction or not. So okay, what we know, we have heat flow. That equation we know, q upon area equals to minus k dt upon dz. And from here what we are going to do, q multiply by dz upon a k equals to minus K here, T1 minus T2. No, this won't be here. So from here, Q dz upon AK plus T1 is equals to T2. So this is T1. We need to calculate temperature at this point. So now already we have Q upon Q, already we have 50 watt, multiply by dz is 10 meter, area is 0.5, and thermal conductivity is 16.5 plus 100. If we solve this, then we will get 116.53. So that is matching with the output we have got through analysis. Okay, thank you for watching. Please like and subscribe my channel.